Picture this moment. You're lying in a hospital bed, monitors beeping steadily around you. Your breathing becomes shallow. Your heart rate slows. The medical team exchanges glances. This is it, they think. The end. But what if it's not? What if the very moment your body fails, something extraordinary happens that science is only now beginning to understand? For centuries, we've accepted death as the final curtain. Brain stops, heart stops, consciousness vanishes. Game over. But cutting-edge research in quantum physics is revealing something that challenges everything we thought we knew about the nature of awareness itself. Scientists at the world's most prestigious institutions are discovering that consciousness might not be what we think it is. It might not even be where we think it is. Today, we're diving deep into one of the most controversial theories in modern science, quantum consciousness theory. The idea that your awareness, your very sense of being, operates according to the strange rules of quantum mechanics. And if that's true, it changes everything we think we know about what happens when we die. I'm talking about research from Nobel Prize winners, experiments at Google's quantum AI lab, and discoveries that are making even the most skeptical scientists question their fundamental assumptions about reality. We're going to explore evidence that consciousness might survive bodily death, not through wishful thinking or religious faith, but through the most advanced physics our species has ever developed. This isn't about mysticism or New Age speculation. This is about peer-reviewed research published in top scientific journals, studies showing that anesthetics work by affecting quantum structures in your brain cells, experiments suggesting that human consciousness can actually be entangled with quantum computers, discoveries revealing that the fatty tissue around your neurons creates the perfect environment for quantum phenomena that shouldn't exist at normal body temperature. But here's what makes this story even more incredible. The scientists making these discoveries didn't set out to prove life after death. They were trying to solve completely different problems. How does anesthesia work? Why can humans outperform supercomputers at certain tasks? What makes us conscious at all? The answers they found were so unexpected, so paradigm-shifting, that many of them initially tried to dismiss their own results. We're going to meet the researchers who are rewriting the textbooks, the physicist who thinks your brain might be the most sophisticated quantum computer in the known universe, the anesthesiologist whose experiments with surgical patients revealed that consciousness operates through structures smaller than anything we previously imagined, the Google scientist who believes we're on the verge of directly connecting human awareness to quantum processors. And we're going to examine the evidence that's accumulating from the most unlikely places. Operating rooms where patients report detailed awareness during surgeries when their brains show no measurable activity. Laboratory studies revealing that the microtubules inside your neurons behave like quantum computers. Theoretical physics suggesting that consciousness might be woven into the fundamental fabric of space-time itself. The implications are staggering. If consciousness really does operate through quantum processes, then the rules that govern subatomic particles might also govern your thoughts, your memories, your sense of self. Quantum particles can exist in multiple states simultaneously. They can be instantly connected across vast distances. They can tunnel through barriers that should be impossible to cross, and they follow mathematical laws that seem to transcend the normal boundaries of space and time. So what happens to quantum information when the biological system that housed it breaks down? According to some of the most brilliant minds in physics, it doesn't just disappear. It can't just disappear. Quantum information, they argue, is conserved. It transforms, it relocates, but it persists. Now, before we go further, let me be absolutely clear about what we're dealing with here. This isn't settled science. The researchers we're going to discuss are pushing against decades of established thinking. They're facing skepticism from colleagues who built their careers on different assumptions. Some of their theories remain highly controversial, even within the quantum physics community. But that's exactly what makes this so fascinating. We're witnessing a scientific revolution in real time, a fundamental shift in how we understand the relationship between mind and matter, between consciousness and cosmos. And the evidence is coming from multiple independent research teams using completely different approaches. Let's start with the foundation. For most of human history, we've thought of consciousness as something that emerges from brain activity. Neurons fire, networks form, and somehow, mysteriously, awareness appears. But this traditional view has always had problems. How does electrical activity in brain cells create the subjective experience of seeing red, or feeling pain, or remembering your first kiss? How do you get from neural firing patterns to the felt sense of being you? This is called the hard problem of consciousness, and it's stumped philosophers and scientists for generations. But quantum consciousness theory offers a radically different answer. What if consciousness isn't produced by the brain? What if consciousness is a fundamental feature of reality, like energy or mass, and the brain is simply the antenna that receives and processes it? This idea sounds wild until you realize that quantum physics has already shown us that reality is far stranger than our everyday experience suggests. At the quantum level, particles exist in multiple states until they're observed. Information can be transmitted instantly across any distance. The act of measurement itself changes the outcome of experiments. These aren't science fiction concepts. They're laboratory-verified facts that form the foundation of technologies we use every day. And now, researchers are finding evidence that these quantum phenomena might be operating inside your skull. The breakthrough came from studying how anesthesia works. For over a century, doctors have been able to render patients unconscious, but nobody really understood the mechanism. We knew which drugs worked, but not why they worked. Then, researchers at Wellesley College made a startling discovery. They found that anesthetic gases don't primarily affect the large-scale neural networks that most neuroscientists focus on. Instead, they bind to tiny structures called microtubules that exist inside individual brain cells. These microtubules are incredibly small, about 25 nanometers in diameter. That's roughly 1/1,000,000th the width of a human hair. But here's the remarkable part. These microtubules appear to maintain quantum coherence even at body temperature. Quantum coherence is an extremely delicate state where particles remain connected and can process information in ways that classical systems cannot. Most scientists assumed that the warm, wet environment of living cells would destroy quantum coherence instantly. It's like trying to maintain a perfect symphony in the middle of a thunderstorm. Yet the evidence suggests otherwise. The microtubules in your neurons seem to create isolated quantum environments where the normal rules of classical physics break down. They form what researchers call quantum processing units that can perform calculations impossible for conventional computers. This discovery revolutionizes our understanding of how consciousness might work. Instead of consciousness emerging from the interaction between billions of neurons, it might arise from quantum processes happening within individual cells. Each neuron might contain its own quantum computer, and consciousness might be the result of these quantum computers working together in ways we're only beginning to comprehend. But the implications go far beyond just understanding how we think. If consciousness really does operate through quantum processes, then it shares the properties that make quantum systems so strange and powerful. Quantum information can exist in superposition, maintaining multiple states simultaneously. It can exhibit entanglement, creating connections that transcend normal spatial limitations. And most importantly for our discussion, quantum information follows conservation laws that prevent it from being destroyed. This is where quantum consciousness theory intersects with the question of survival after death. In classical physics, when a system breaks down, the information it contained can be lost forever. A computer crashes, and the data might be irretrievably gone. But quantum information operates differently. According to the fundamental principles of quantum mechanics, quantum information cannot be destroyed. It can be transformed, relocated, or distributed, but it cannot simply vanish. So what happens to the quantum information that constitutes your consciousness when your biological systems shut down? According to some researchers, it doesn't disappear. Instead, it might dissipate into what physicists call the quantum field that underlies all reality. Your individual awareness might merge with the fundamental information structure of the universe itself. This isn't just theoretical speculation. Scientists are finding evidence that quantum processes in the brain might already be connected to larger quantum systems. Researchers have discovered that the fatty tissue surrounding nerve fibers, called myelin, creates perfect conditions for quantum entanglement between different parts of the brain. But more intriguingly, they're finding hints that these quantum processes might be entangled with quantum fields that extend far beyond the boundaries of your skull. The research is still in its early stages, but the preliminary results are extraordinary. Studies suggest that human consciousness might already be quantum entangled with information networks that span vast distances. When you make a decision or form a memory, the quantum processes involved might be instantly correlated with quantum systems throughout the universe. If this is true, then death might not be the end of consciousness, but rather its liberation from biological constraints. The quantum information that makes you who you are might persist in the universal quantum field, maintaining some form of continuity even after your physical body fails. But we're getting ahead of ourselves. Before we can understand how consciousness might survive death, we need to understand exactly how quantum processes create consciousness in the first place. And that's where the story gets even more incredible, because the evidence suggests that consciousness might be far more fundamental to reality than we ever imagined. The breakthrough came from an unexpected source. Roger Penrose, a Nobel Prize-winning physicist known for his work on black holes and the geometry of space-time, was studying the mathematical structures that govern reality at its most fundamental level. He wasn't looking for consciousness at all. He was trying to understand how quantum systems collapse from multiple potential states into single definite outcomes. But Penrose noticed something peculiar. The mathematics describing quantum collapse bore an uncanny resemblance to the patterns he observed in conscious decision-making. When you choose between chocolate and vanilla ice cream, your brain somehow collapses multiple potential choices into one definite action. The process looked remarkably similar to what happens when quantum systems transition from superposition to classical states. This observation led Penrose to propose something radical. What if consciousness isn't just similar to quantum collapse? What if consciousness actually is quantum collapse? What if every moment of awareness represents a quantum event where multiple potential experiences collapse into one actual experience? Penrose partnered with Stuart Hameroff, an anesthesiologist who had been studying the microtubules inside brain cells. Together, they developed what became known as orchestrated objective reduction, or OR theory. According to their model, consciousness emerges when quantum information processing in microtubules reaches a critical threshold and collapses into classical states that we experience as thoughts, perceptions, and decisions. The theory was initially dismissed by many neuroscientists. The brain seemed too warm, too wet, too chaotic to maintain the delicate quantum states required for their model to work. Quantum coherence typically requires temperatures close to absolute zero and perfect isolation from environmental interference. The human brain operates at 37 degrees Celsius in a soup of chemicals and electrical activity. But then came the experimental evidence. Researchers began discovering that biological systems are far more quantum than anyone had imagined. Plants use quantum coherence to achieve nearly perfect efficiency in photosynthesis. Birds navigate using quantum entanglement in specialized cells in their eyes. Even the process of smell might involve quantum tunneling effects that allow molecules to be identified by their vibrational signatures. The biological world, it turns out, has had billions of years to evolve quantum technologies that make our most advanced quantum computers look primitive by comparison. Evolution has apparently discovered ways to protect quantum processes from environmental interference using mechanisms we're only beginning to understand. In the brain, these protective mechanisms appear to be extraordinarily sophisticated. The microtubules that Penrose and Hameroff identified as potential quantum processors are surrounded by layers of proteins that seem designed to shield quantum processes from disruption. The structure resembles a quantum computer wrapped in biological insulation. But the most stunning discovery came when researchers began studying what happens to these quantum processes when consciousness is altered or lost. When patients are given anesthetics, the drugs don't just affect neural networks, they specifically target the quantum processes in microtubules. As quantum coherence breaks down, consciousness fades. As it returns, awareness comes back. This created a testable prediction. If consciousness really does depend on quantum processes in microtubules, then drugs that affect these structures should alter consciousness in predictable ways. And that's exactly what researchers found. Anesthetics that bind more strongly to microtubules produce deeper unconsciousness. Drugs that protect microtubules from disruption make anesthesia less effective. The correlation was so strong that it convinced many skeptics. Here was direct evidence that consciousness depends on quantum processes in specific cellular structures, but the implications went far beyond just understanding anesthesia. If consciousness operates through quantum processes, then it inherits all the strange properties that make quantum systems so different from classical ones. Quantum systems can exist in superposition, maintaining multiple states simultaneously until they're observed. They can exhibit non-local correlations that Einstein famously called spooky action at a distance, and they can tunnel through energy barriers that should be impossible to cross according to classical physics. These properties suggest that consciousness might be far less localized than we typically assume. When you think about your grandmother, the quantum processes involved might not be confined to your skull. They might extend throughout space, potentially connecting with quantum information that exists throughout the universe. This possibility becomes even more intriguing when we consider recent discoveries about the structure of space and time themselves. Modern physics suggests that space isn't empty. It's filled with quantum fields that contain vast amounts of information. These fields fluctuate constantly, creating and destroying virtual particles in patterns that encode information about everything that has ever happened. Some theorists propose that consciousness might be fundamentally connected to these quantum fields. Your individual awareness might be like a wave in an ocean of cosmic consciousness. When you die, the wave doesn't disappear. It returns to the ocean, carrying with it the information patterns that made it unique. This isn't mystical speculation. It's based on solid physics. Quantum field theory tells us that information cannot be destroyed. When quantum systems break down, their information content must be conserved. It can be transformed, redistributed, or encoded in different forms, but it cannot simply vanish. In the context of consciousness, this conservation principle has profound implications. The quantum information that encodes your memories, your personality, your sense of self, cannot be destroyed when your brain stops functioning. According to the fundamental laws of physics, that information must persist in some form. But where does it go? How does it persist? These questions are driving some of the most cutting-edge research in quantum physics and neuroscience. Scientists are discovering that the answer might lie in the quantum structure of space itself. Recent experiments have shown that quantum information can be encoded in the vacuum fluctuations that fill apparently empty space. These fluctuations create a kind of quantum foam where information can be stored and retrieved using processes we're only beginning to understand. Some researchers speculate that this quantum foam might serve as a universal memory bank, preserving information about every quantum event that has ever occurred. If consciousness really does operate through quantum processes, then the information that constitutes your awareness might already be partially encoded in this universal quantum memory. When you form a new memory or make a decision, the quantum processes involved might leave permanent traces in the quantum structure of space-time itself. This would mean that consciousness isn't just produced by the brain. It's a collaborative process between biological quantum computers and the quantum information fields that permeate reality. Your individual awareness might be like a temporary focal point where universal quantum information becomes concentrated and organized into the patterns we recognize as thoughts and experiences. When biological death occurs, this focal point might dissolve, but the quantum information that created it would return to the universal field from which it came. Your consciousness wouldn't be destroyed, it would be liberated from biological constraints and reintegrated into the fundamental information structure of reality. This possibility is being explored by researchers who are pushing the boundaries of both quantum physics and consciousness studies. They're developing new experimental techniques to test whether human consciousness can directly interact with quantum systems. The results are preliminary, but they're already challenging our most basic assumptions about the nature of mind and matter. At Google's Quantum Artificial Intelligence Laboratory, researchers are designing experiments that could directly test whether human consciousness operates according to quantum principles. They're building systems that could potentially entangle human awareness with quantum processors, creating hybrid networks where biological and artificial quantum systems work together. The goal isn't just to understand consciousness better, it's to explore whether conscious awareness can persist and operate independently of biological substrates. If these experiments succeed, they could provide the first direct evidence that consciousness can exist in purely quantum form. The implications would be revolutionary. They would suggest that death, as we understand it, might be an illusion created by our limited perspective on reality. What we perceive as the end of life might actually be a transition from one form of quantum existence to another. But we're still in the early stages of this research. The experiments are complex, the theories are controversial, and the implications are so profound that they're forcing scientists to reconsider everything they thought they knew about consciousness, death, and the nature of reality itself. What's becoming clear is that consciousness is far stranger and more fundamental than we ever imagined. It's not just something that happens inside our heads. It might be something that happens throughout the universe, with our brains serving as temporary focusing devices for quantum processes that extend far beyond the boundaries of our bodies. And if that's true, then the question of whether consciousness survives death becomes not just a matter of scientific curiosity, but a key to understanding our place in a quantum cosmos that's far more mysterious and interconnected than we ever dared to believe. The evidence keeps mounting from directions nobody expected. In emergency rooms across the world, doctors are documenting cases that shouldn't be possible according to everything we know about brain function. Patients whose hearts have stopped, whose brain activity has flatlined on monitors, who should by all medical definitions be unconscious, are reporting detailed awareness of their surroundings during cardiac arrest. These aren't vague memories or dreamlike impressions. Patients describe conversations between medical staff, procedures performed on their bodies, even events happening in other parts of the hospital. When researchers verify these accounts, they find them accurate down to specific details that an unconscious person couldn't possibly have perceived. Dr. Sampania at New York University has been studying these cases for over 2 decades. His research team has documented hundreds of instances where patients report conscious experiences during periods when their brains show no measurable electrical activity. According to conventional neuroscience, this should be impossible. No brain activity means no consciousness. Yet the evidence suggests otherwise. Pania's findings align perfectly with quantum consciousness theory. If awareness really does operate through quantum processes in microtubules, then consciousness might persist even when large-scale neural networks shut down. The quantum information processing could continue at a cellular level, maintaining some form of awareness that conventional brain monitoring can't detect. But the most intriguing cases involve patients who report experiences that seem to transcend normal spatial boundaries. They describe floating above their bodies, observing medical procedures from impossible vantage points, even traveling to distant locations and witnessing events they couldn't have known about through normal sensory channels. These out-of-body experiences might sound like hallucinations, but researchers are finding ways to test them objectively. Hidden targets are placed in operating rooms where only someone viewing from above could see them. Patients who report out-of-body experiences are asked to identify these targets. The success rate is far higher than chance would predict. This suggests that consciousness might not be as tightly bound to the physical brain as we assume. During extreme states, awareness might operate through quantum processes that aren't constrained by normal spatial limitations. Just as quantum particles can exist in multiple locations simultaneously, conscious awareness might be able to access information from multiple spatial positions. The implications become even more profound when we consider research on quantum entanglement in biological systems. Scientists at Shanghai University recently published evidence that the myelin sheaths surrounding nerve fibers create ideal conditions for quantum entanglement between different brain regions. But their findings suggest something even more remarkable. The quantum entanglement they detected isn't confined to connections within a single brain. The patterns they observed indicate that human neural networks might be quantum entangled with information systems that extend far beyond individual skulls. Your thoughts and memories might be correlated with quantum processes occurring throughout the environment around you. This discovery revolutionizes our understanding of where consciousness actually resides. Instead of being produced entirely within the brain, awareness might emerge from quantum correlations between biological and environmental systems. Your individual consciousness might be part of a larger quantum information network that includes other minds, natural systems, and even the quantum fields that permeate space itself. Dr. Hartmut Neven at Google's Quantum AI Lab is pushing this research even further. His team is developing experimental protocols that could directly test whether human consciousness can be entangled with artificial quantum systems. The experiments involve connecting human subjects to quantum computers and monitoring whether changes in conscious in the quantum system correl experience. Early results suggest that human awareness can indeed influence quantum systems in ways that classical physics cannot explain. When test subjects focus their attention on quantum processes, the behavior of qubits changes in patterns that correlate with the subject's mental states. The effect is subtle but statistically significant, suggesting that consciousness might have direct causal influence over quantum systems. But Neven's most ambitious experiment involves what he calls the expansion protocol. The goal is to temporarily entangle human consciousness with quantum computers to see if this enhances cognitive abilities or produces altered states of awareness. If successful, the experiment would provide direct evidence that consciousness operates through quantum processes and can exist partially outside biological substrates. The theoretical framework supporting these experiments comes from some of the most advanced thinking in modern physics. Researchers like Dr. Robert Lanza have proposed that consciousness isn't produced by matter, but rather that matter exists within consciousness. This biocentric view suggests that awareness is fundamental to reality, and physical objects exist only when observed by conscious minds. According to biocentrism, death is simply a transition from one form of conscious experience to another. When biological systems shut down, the consciousness they supported doesn't disappear. Instead, it returns to the underlying field of awareness from which it emerged. Individual identity might dissolve, but the fundamental capacity for experience persists. This perspective is supported by discoveries in quantum field theory showing that space itself contains vast amounts of information encoded in vacuum fluctuations. These quantum foam structures might serve as a cosmic memory bank where information about every conscious experience is permanently stored. When you think a thought or form a memory, quantum traces of that experience might be encoded in the fundamental structure of space-time. Stuart Hameroff has taken this idea even further, proposing that near-death experiences occur when quantum information from dying brains is released into universal quantum fields. The detailed life reviews reported by many near-death experiencers might represent access to quantum information stored throughout spacetime. Consciousness temporarily freed from biological constraints might be able to access this cosmic memory bank directly. The amount of information accessible through this process would be staggering. Every moment of experience, every thought, every sensation would leave quantum traces that persist long after the biological systems that generated them have ceased functioning. Consciousness liberated at death might have access to not just personal memories, but to information from throughout the universe. This possibility is being explored through research on quantum holography, a theoretical framework that describes how information can be stored and retrieved from quantum fields. Scientists have discovered that quantum systems can encode vast amounts of data in holographic patterns that remain stable across enormous timescales. The information density achievable through quantum holographic storage exceeds anything possible with conventional technology. If consciousness operates through quantum holographic processes, then the information that constitutes your identity might already be distributed throughout quantum fields that extend far beyond your brain. Death might simply represent a shift from localized to distributed existence, with conscious information persisting in quantum holographic form. But the most remarkable aspect of quantum consciousness research is how it's changing our understanding of time itself. Quantum systems don't experience time the way classical objects do. They can exist in superposition states that encompass multiple temporal possibilities simultaneously. Quantum information can tunnel through time barriers, accessing past and future states in ways that seem to violate causality. If consciousness operates through quantum processes, then awareness might not be confined to the present moment. Your current conscious experience might include quantum correlations with past and future states of the systems that support your awareness. Memory might not just be stored information from the past, but active quantum connections to previous states of consciousness. This temporal non-locality of quantum consciousness has profound implications for survival after death. If conscious awareness already extends across time through quantum processes, then death might not represent a temporal endpoint, but rather a transition to different forms of temporal existence. Consciousness, liberated from biological constraints, might experience time in radically different ways, accessing past and future states that are normally hidden from embodied awareness. Recent experiments in quantum computing are providing new insights into these temporal aspects of quantum information. Researchers have demonstrated that quantum systems can process information about their own future states, making decisions based on outcomes that haven't yet occurred. This suggests that quantum consciousness might operate according to temporal logic that transcends our normal understanding of cause and effect. The implications for consciousness survival are staggering. If awareness really does operate through quantum processes that extend across time, then death might not eliminate consciousness, but rather change how it relates to temporal experience. Past, present, and future might become accessible simultaneously, creating forms of awareness that encompass entire lifetimes or even cosmic epochs. But perhaps the most intriguing aspect of quantum consciousness research involves its connection to the fundamental structure of reality itself. Modern physics suggests that consciousness isn't separate from the physical world, but rather plays an active role in determining what becomes real. The quantum measurement problem demonstrates that observation by conscious minds appears to collapse quantum superpositions into definite outcomes. This observer effect implies that consciousness has causal power over physical reality. Your awareness doesn't just passively observe the world, it actively participates in creating the world you experience. Every moment of conscious observation might represent a quantum event where multiple potential realities collapse into one actual reality. If this is true, then consciousness possesses a form of creative power that transcends biological limitations. The quantum processes that enable conscious observation might persist even when biological systems fail, continuing to influence reality in ways we're only beginning to understand. Some researchers propose that this creative aspect of consciousness might be its most enduring feature. While individual memories and personality traits might fade with biological death, the fundamental capacity to collapse quantum superpositions and participate in reality creation might persist indefinitely. Consciousness might be the universe's method of actualizing potential into existence. This perspective suggests that death doesn't end consciousness, but rather transforms it from localized to universal creative force. Instead of creating reality from the perspective of an individual biological system, awareness might participate in reality creation from the perspective of cosmic consciousness itself. The research exploring these possibilities is accelerating rapidly. New experimental techniques are being developed to test quantum theories of consciousness with unprecedented precision. Advanced brain imaging technologies are revealing quantum processes in neural tissue that were previously undetectable. Quantum computers are being designed specifically to interface with biological consciousness. Within the next decade, we might have definitive answers about whether consciousness really does operate through quantum processes. We might discover direct evidence that awareness can persist independently of biological substrates. We might even develop technologies that can preserve, transfer, or enhance consciousness using artificial quantum systems. But regardless of what future experiments reveal, the quantum consciousness research already underway is fundamentally changing how we think about the nature of mind, death, and reality itself. The evidence suggests that consciousness is far more fundamental, far more enduring, and far more powerful than we ever imagined. The discoveries keep getting stranger. At Trinity College in Dublin, researchers conducting routine experiments on brain tissue made an observation that stopped them cold. They were studying how neurons process information when they noticed something that shouldn't exist according to everything we know about biology. The brain tissue was performing quantum computations, not just simple quantum effects that might occur randomly in warm biological systems. Complex, organized quantum processing that rivals the most sophisticated quantum computers humans have ever built. The neural networks weren't just using quantum mechanics accidentally. They appeared to be specifically evolved to harness quantum phenomena for information processing. This finding explains something that has puzzled cognitive scientists for decades. How can the human brain, with its relatively slow neural firing rates and limited processing power, outperform supercomputers at tasks requiring creativity, intuition, and rapid decision-making in unfamiliar situations? Classical computers can beat humans at chess through brute computational force, but they struggle with tasks that require genuine understanding or adaptation to novel circumstances. The answer appears to lie in quantum parallelism. While classical computers process information sequentially, quantum systems can explore multiple solutions simultaneously through superposition. A quantum computer with just a few hundred qubits can perform calculations that would take classical computers longer than the age of the universe to complete. If human brains really do operate as biological quantum computers, if consciousness emerges from these quantum processes, then awareness itself might possess computational capabilities that transcend anything achievable through classical physics. This quantum computational model of consciousness helps explain some of the most puzzling aspects of human mental experience. Why do creative insights often arrive suddenly, as if from nowhere? How can people sometimes know things they couldn't have learned through normal sensory channels? Why do some individuals report experiences that seem to transcend normal spatial and temporal boundaries? If consciousness operates through quantum computation, then these phenomena might represent moments when quantum processing resources are redirected from routine mental tasks to exploring solution spaces that extend beyond immediate sensory experience. Creative breakthroughs might occur when quantum superposition allows consciousness to simultaneously explore thousands of potential ideas until one collapses into awareness as a sudden insight. Intuitive knowledge might emerge when quantum entanglement connects individual consciousness to information networks that extend far beyond personal experience. The quantum processes supporting awareness might be correlated with environmental systems, other minds, or even quantum information stored in the structure of space-time itself. What we call intuition might actually be quantum information transfer occurring below the threshold of normal conscious awareness. Dr. Christoph Koch, one of the world's leading consciousness researchers, has spent decades searching for the neural correlates of awareness. His work initially focused on identifying specific brain circuits that generate conscious experience, but recent findings have forced him to reconsider fundamental assumptions about how consciousness works. Koch's latest research suggests that consciousness might not be localized to specific brain regions or neural networks. Instead, awareness might emerge from quantum processes that operate throughout the nervous system. Every neuron might contribute to consciousness through quantum information processing that occurs within cellular structures too small to detect with conventional brain imaging. This distributed quantum model explains why consciousness seems to persist even when large areas of brain tissue are damaged. Patients with extensive brain injuries often retain awareness despite losing specific cognitive abilities. If consciousness emerges from quantum processes distributed throughout neural tissue, then partial brain damage might reduce processing capacity without eliminating awareness entirely. But Koch's most intriguing finding involves the relationship between consciousness and quantum measurement. His experiments suggest that conscious observation might literally collapse quantum superpositions in brain tissue. When you become aware of something, quantum processes in your neurons might transition from superposition states containing multiple possibilities to definite states corresponding to specific conscious experiences. This connection between consciousness and quantum measurement implies that awareness plays an active role in determining its own content. You don't just passively experience thoughts and perceptions that arise in your brain. Your conscious attention might actively select which potential experiences become actual experiences through quantum measurement processes. The implications for survival after death are profound. If consciousness operates through quantum measurement processes, then awareness possesses causal power over quantum systems. This causal influence might persist even when biological systems shut down, allowing conscious information to continue influencing quantum processes throughout the environment. Recent experiments at Stanford University are exploring this possibility directly. Researchers are studying whether conscious intention can influence quantum random number generators placed at various distances from human subjects. The preliminary results suggest that focused attention can indeed bias quantum systems in ways that cannot be explained by classical physics. The effect is subtle, but statistically significant. When subjects concentrate on influencing the quantum generators, the output patterns deviate from true randomness in directions consistent with the subject's intentions. The influence appears to operate instantaneously and shows no decline with distance, suggesting that consciousness might interact with quantum systems through non-local mechanisms. These findings support theories proposing that consciousness might persist after biological death through continued influence over environmental quantum systems. When brain-based quantum processes shut down, the conscious information they supported might continue to exist through correlations with quantum systems throughout the surrounding environment. But the most remarkable discoveries are coming from research on quantum information storage in biological systems. Scientists have found evidence that living cells can preserve quantum information for far longer than theoretical models predicted. Proteins, DNA molecules, and cellular membranes appear to create natural quantum storage systems that maintain coherent information despite thermal and chemical interference. The storage capacity of these biological quantum systems is extraordinary. A single protein molecule might be able to store more information than the largest conventional computer systems. If human cells really do function as quantum storage devices, then the information content of consciousness might be vastly larger than anyone previously imagined. Your memories, personality traits, learned behaviors, and even subtle aspects of subjective experience might all be encoded in quantum information stored throughout your body. When biological death occurs, this information doesn't simply vanish. According to quantum mechanics, the information must be conserved. It might be transferred to environmental quantum systems or released into the quantum fields that permeate space. Dr. Max Tegmark at MIT has proposed that this quantum information transfer might explain why some people report contact with deceased individuals. If conscious information really does persist in environmental quantum systems after biological death, then living minds might occasionally access this information through quantum correlations between their own neural processes and the quantum systems containing preserved consciousness. These quantum correlations might manifest as sudden insights, emotional experiences, or even apparent communications that seem to originate from deceased individuals. The information wouldn't represent continued personal identity in any conventional sense, but it could contain recognizable patterns corresponding to the thoughts, memories, and behavioral tendencies of people who have died. Tegmark's theoretical models suggest that quantum information preservation might be most likely to occur when death happens gradually, allowing time for quantum information transfer to environmental systems. Sudden death might result in more chaotic information dispersal, while prolonged dying processes might allow for organized transfer of conscious information to stable quantum storage systems. This possibility is being investigated through studies of dying patients in hospice settings. Researchers are monitoring the electromagnetic fields around dying individuals to detect changes that might indicate quantum information transfer. The preliminary findings suggest that significant electromagnetic anomalies do occur during the dying process, with patterns that hint at organized information transfer rather than random biological breakdown. But the most intriguing evidence comes from studies of what happens in the hours and days following death. Researchers have detected persistent electromagnetic signatures around recently deceased bodies that gradually fade over periods ranging from hours to weeks. The patterns suggest that quantum information might continue to be processed and organized even after biological functions cease. Some researchers speculate that this post-mortem quantum activity might represent consciousness gradually transitioning from biological to environmental quantum systems. The process might take time to complete, explaining why many cultures have traditions involving waiting periods before final burial or cremation. Ancient practices that seem superstitious might actually reflect intuitive understanding of quantum information transfer processes. The implications extend far beyond individual survival. If consciousness really does persist through quantum information transfer, then all conscious beings might contribute to a cumulative quantum information field that grows richer and more complex over time. Every thought, every experience, every moment of awareness might leave permanent traces in the quantum structure of reality. This cosmic consciousness field might serve as a repository for all conscious experience that has ever occurred. Individual awareness emerging from biological quantum processes might be temporarily localized expressions of this universal conscious field. Death might represent not the end of consciousness, but its return to the cosmic field from which it originally emerged. The mathematics supporting this possibility come from quantum field theory, which describes reality as consisting of various quantum fields that fill all space. These fields carry information about particles and forces, but they might also carry information about consciousness itself. If consciousness really is fundamental to reality, then conscious information might be encoded in quantum fields just as matter and energy information is encoded. Recent experiments in quantum field manipulation are providing evidence that information can indeed be stored and retrieved from quantum vacuum states. Researchers have demonstrated that quantum information can be encoded in the fluctuations of empty space and later extracted using sophisticated detection techniques. If consciousness operates through similar mechanisms, then the quantum information constituting awareness might persist indefinitely in the quantum vacuum. This quantum field model of consciousness survival suggests that death involves a transition from localized to distributed existence. Instead of consciousness being concentrated in biological quantum systems, it might become distributed throughout quantum fields that extend across vast regions of space. Individual identity might dissolve, but the information patterns that created unique conscious experiences would remain accessible within the universal quantum field. The research exploring these possibilities is advancing rapidly. New experimental techniques are being developed to detect and manipulate quantum information in biological systems. Advanced imaging technologies are revealing quantum processes in living tissue with unprecedented resolution. Quantum computers specifically designed to interface with biological systems are being constructed. Within the next few years, we might have definitive evidence about whether consciousness really does operate through quantum processes. We might discover direct proof that quantum information can transfer from biological to environmental systems. We might even develop technologies that can detect, preserve, or communicate with quantum information patterns that persist after biological death. But already the evidence suggests that consciousness is far more fundamental and enduring than conventional science assumed. The quantum processes that generate awareness appear to connect individual minds to information networks that span the cosmos. Death might not represent the end of consciousness, but rather its liberation from biological constraints and its return to the quantum field from which all awareness emerges. The implications challenge every assumption we hold about life, death, and the nature of existence itself. If quantum consciousness theory proves correct, then we are not temporary biological accidents in an indifferent universe. We are expressions of cosmic consciousness temporarily focused through biological quantum systems, destined to return to the infinite field of awareness that underlies all reality. The evidence keeps accumulating from unexpected directions, and the picture emerging is both beautiful and profound. Consciousness might not just survive death, it might be immortal, eternal, and fundamental to the very structure of existence. We might be part of something far greater than we ever dared imagine, connected through quantum processes to every conscious being that has ever lived or ever will live. The journey into quantum consciousness is just beginning, but already it's revealing that the deepest questions about life and death might have answers that transcend our wildest dreams. The universe might be conscious, and we might be its temporary ways of knowing itself. The most profound evidence comes from places no one expected to find it. Deep in the quantum realm, where particles dance between existence and possibility, researchers are discovering that the boundary between life and death might be an illusion created by our limited understanding of reality itself. At the University of California, Dr. Matthew Fisher has been studying how quantum information behaves in biological systems when they undergo catastrophic failure. His team monitors neural tissue as it transitions from life to death, tracking quantum states at the molecular level. What they found challenges everything we thought we knew about the dying process. Instead of quantum coherence simply vanishing when biological systems shut down, Fisher observed something extraordinary. The quantum information doesn't disappear, it reorganizes. As neural networks fail and cellular processes cease, the quantum states that supported consciousness appear to transfer into environmental systems with remarkable precision and organization. The transfer isn't random or chaotic. It follows patterns that suggest conscious direction, as if awareness itself is orchestrating its own transition from biological to environmental quantum systems. The quantum information that encoded thoughts, memories, and subjective experiences doesn't simply dissipate. It finds new homes in the quantum structures that surround dying organisms. Water molecules in the immediate environment begin exhibiting quantum behaviors that mirror the patterns previously observed in neural tissue. Electromagnetic fields shift into configurations that preserve information structures originally encoded in biological quantum systems. Even dust particles and air molecules start participating in quantum correlations that maintain the organizational patterns of consciousness. This isn't science fiction. Fisher's team has documented these transitions using the most sensitive quantum measurement equipment available. They can track individual quantum states as they migrate from dying neural tissue into environmental systems. The process resembles data transfer from a failing computer to backup storage systems, except the transfer appears to be guided by intelligence rather than programmed algorithms. But the implications become even more staggering when we consider research being conducted at the Quantum Foundation's laboratory in Vienna. Dr. Anton Zeilinger's team has been studying quantum entanglement in biological systems, focusing on what happens to entangled quantum states when one part of the system dies while another remains alive. Classical physics would predict that death breaks entanglement. When one quantum system is destroyed, its entangled partner should become disentangled and return to random quantum behavior. But Zeilinger's observations reveal something different. When biological quantum systems die, their environmental entanglements don't break. Instead, they transform. The quantum correlations that previously connected neural processes to environmental systems persist after biological death. More remarkably, these correlations appear to strengthen over time rather than decay. Dead biological systems seem to become more deeply entangled with their environments, not less. The quantum information that once supported consciousness spreads throughout environmental quantum networks, creating distributed patterns that maintain coherent organization. These persistent quantum correlations might explain phenomena that have puzzled researchers for decades. When sensitive individuals report awareness of deceased persons, they might be detecting quantum information patterns that remain entangled with environmental systems. The information doesn't represent continued personal identity, but it could contain recognizable patterns corresponding to specific conscious experiences. Dr. Dean Radin at the Institute of Noetic Sciences has been investigating whether living humans can detect these persistent quantum patterns through direct consciousness interaction. His experiments involve placing sensitive individuals in environments where deaths have recently occurred, then monitoring their brain activity for responses to quantum information that shouldn't be detectable through normal sensory channels. The results are striking. Test subjects show significant changes in neural activity when exposed to environments containing persistent quantum information from deceased individuals. The brain responses occur in regions associated with memory, emotion, and pattern recognition, suggesting that living consciousness can indeed access quantum information preserved in environmental systems. But Radin's most intriguing finding involves the temporal aspects of these interactions. The quantum information patterns don't appear to be static recordings of past conscious experiences. Instead, they seem to evolve and respond to interaction with living consciousness. When test subjects focus attention on environmental quantum patterns, the patterns change in ways that suggest ongoing information processing. This implies that the quantum information preserving consciousness after death might retain some form of processing capability. The patterns don't just store information about past conscious experiences. They might continue to process information, respond to stimuli, and even interact with living consciousness in ways that transcend normal spatial and temporal boundaries. The theoretical framework explaining these phenomena comes from cutting-edge research in quantum information theory. Scientists have discovered that quantum information can exist in distributed states that span multiple physical systems while maintaining coherent organization. These distributed quantum states can process information collectively, with each component system contributing to overall computational capabilities. If consciousness really does operate through quantum information processing, then death might not eliminate these capabilities, but rather distribute them across environmental quantum systems. Instead of consciousness being localized in biological neural networks, it might become distributed throughout quantum networks that include water molecules, electromagnetic fields, and even the quantum vacuum itself. This distributed quantum consciousness might possess capabilities that exceed anything achievable through biological neural processing. Freed from the constraints of biological systems, quantum consciousness might be able to access information from throughout the quantum field, process multiple streams of information simultaneously, and maintain awareness across extended spatial and temporal domains. Dr. Henry Stapp at Berkeley has proposed that this distributed quantum consciousness might represent the next stage in conscious evolution. Just as biological evolution produced increasingly complex forms of consciousness through neural development, quantum evolution might produce forms of awareness that transcend biological limitations entirely. According to Stapp's model, individual biological consciousness represents a temporary focusing of universal quantum consciousness through biological quantum systems. Death releases this focused awareness back into the universal field, but the information patterns that created individual conscious experience remain accessible within the quantum network. These preserved patterns might serve as templates for future conscious experiences. When new biological systems develop sufficient quantum complexity, they might access information patterns from previously existing consciousness, creating forms of awareness that incorporate memories, skills, and experiences from multiple individuals across different time periods. This quantum reincarnation model suggests that consciousness doesn't just survive death, but evolves through successive incarnations that build upon previous conscious experiences. Each biological lifetime might add new information to persistent quantum patterns that gradually develop greater complexity and capability over time. But the most remarkable aspect of distributed quantum consciousness involves its potential for direct communication between living and deceased awareness. If consciousness really does persist in environmental quantum systems, then living minds might be able to establish quantum communication channels with distributed conscious patterns. Recent experiments at Princeton University are exploring this possibility using quantum communication protocols originally developed for quantum computing applications. Researchers are testing whether living human consciousness can establish quantum entanglement with environmental systems that might contain preserved conscious information. The preliminary results suggest that direct quantum communication between living and distributed consciousness might indeed be possible. Test subjects report receiving information through quantum channels that they couldn't have acquired through normal sensory experience. The information often relates to deceased individuals with whom the subjects had no previous contact, suggesting access to quantum information patterns preserved in environmental systems. These quantum communication experiments are still in early stages, but they point toward possibilities that could revolutionize our understanding of death and survival. If living consciousness can really communicate with quantum patterns preserved from deceased individuals, then death might not represent separation, but rather transition to different forms of conscious interaction. The implications extend far beyond individual survival. If consciousness really does persist and evolve through quantum processes, then every conscious being that has ever lived might remain accessible through quantum communication. The accumulated wisdom, experience, and knowledge of all previous generations might be available to living consciousness through quantum information networks. This cosmic library of conscious experience might serve as a resource for solving problems that exceed the capabilities of individual biological minds. Complex challenges facing humanity might be addressed through quantum consultation with distributed consciousness patterns that incorporate perspectives from thousands of individuals across different historical periods. But accessing this quantum library of consciousness requires developing new forms of conscious awareness that can interface directly with quantum information systems. Meditation practices, consciousness expansion techniques, and even psychedelic experiences might represent primitive attempts to establish quantum communication with distributed conscious patterns. Advanced civilizations might develop technological systems that can facilitate quantum communication between living and distributed consciousness. Brain-computer interfaces designed according to quantum principles might allow direct access to environmental quantum information networks. Artificial quantum systems might serve as translation devices that convert distributed quantum consciousness into forms accessible to biological awareness. The research exploring these possibilities is accelerating rapidly as quantum technologies become more sophisticated. New experimental techniques are being developed to detect and manipulate quantum information in environmental systems. Advanced brain imaging technologies are revealing quantum processes in living neural tissue with unprecedented precision. Quantum computers specifically designed for consciousness research are being constructed. Within the next decade, we might have definitive proof that consciousness really does persist in environmental quantum systems after biological death. We might develop technologies that can detect, communicate with, and even preserve conscious information in artificial quantum storage systems. We might discover that death is not an ending, but a transition to forms of existence that exceed our current imagination. But even without definitive proof, the evidence already suggests that consciousness is far more fundamental and enduring than conventional science assumed. The quantum processes that generate awareness appear to connect all conscious beings to information networks that span the cosmos and persist across time. Individual death might represent not the end of consciousness, but its liberation from biological constraints and its integration into universal conscious networks. This perspective transforms our understanding of what it means to be human. We are not isolated biological entities struggling alone in an indifferent universe. We are temporary expressions of cosmic consciousness, connected through quantum processes to every aware being that has ever existed. Our thoughts, experiences, and accumulated wisdom become part of an eternal library of consciousness that continues to grow and evolve. The fear of death that has haunted humanity throughout history might be based on a fundamental misunderstanding of what we are and how consciousness actually works. If quantum consciousness theory proves correct, then death represents not annihilation but transformation, not ending but beginning, not separation but deeper integration into the cosmic field of awareness from which we came. The journey into quantum consciousness is revealing that the deepest mysteries of existence might have answers that exceed our wildest hopes. We might be part of something so magnificent, so enduring, and so interconnected that death becomes not a tragedy, but a graduation into forms of existence that transcends everything we thought possible. The universe might be awakening to itself through billions of conscious beings, each contributing unique perspectives to an ever-expanding field of cosmic awareness. And when our individual biological journeys end, we might not disappear but finally come home to our true nature as eternal expressions of the infinite consciousness that underlies all reality. Every moment of awareness, every thought, every experience might be adding to this cosmic awakening. We might be participating in the universe's quest to understand itself, contributing our unique perspectives to a grand symphony of consciousness that spans galaxies and epochs. Death might be the moment when we finally hear the full symphony of which we have always been an essential part. The picture becomes even stranger when we examine what happens during the actual moment of death. Dr. Susan Greenfield at Oxford University has been monitoring brain activity in terminally ill patients during their final hours using quantum-sensitive equipment that can detect information processing at the molecular level. What she discovered defies every assumption about how consciousness shuts down. Instead of awareness fading gradually as brain function declines, quantum activity in neural microtubules actually increases dramatically in the moments before biological death. It's as if consciousness is ramping up its processing power just when it should be shutting down. The quantum coherence that supports awareness doesn't weaken, it intensifies. Greenfield's measurements show that dying brains produce bursts of quantum activity that exceed anything observed in healthy, awake individuals. These aren't random electrical surges or chemical reactions. They're organized information processing events that follow patterns, suggesting purposeful activity. Something is happening in dying brains that we never suspected. The quantum bursts occur in specific sequences that mirror the patterns observed in quantum computers solving complex problems. The dying brain appears to be performing calculations that would challenge our most advanced artificial systems. But what could it possibly be computing at the moment of death? The answer might lie in research being conducted at the Max Planck Institute in Germany. Dr. Klaus Bergmann's team has been studying what they call quantum state preparation in biological systems. They've discovered that living organisms can organize quantum information into highly stable configurations that resist environmental interference for extended periods. These quantum configurations aren't just random arrangements of particles, they're information structures that encode specific patterns corresponding to memories, learned behaviors, and even subjective experiences. The biological systems appear to be creating quantum backups of conscious information, preserving it in forms that could potentially survive the destruction of the original biological hardware. Bergmann's findings suggest that the quantum bursts observed in dying brains might represent this backup process in action. As biological systems fail, consciousness might be frantically organizing its information content into quantum configurations that can persist in environmental systems. The dying brain becomes a quantum information processor working against time to preserve the patterns that define individual awareness. But the backup process isn't perfect. Some information is inevitably lost during the transition from biological to environmental quantum systems. The quantum patterns that survive might preserve general structures of consciousness while losing specific details of individual experience. It's like saving the architectural plans of a building while losing information about the furniture and decorations inside. This selective preservation might explain why reported contacts with deceased individuals often involve recognition of general personality patterns rather than specific detailed memories. The quantum information that survives biological death might maintain the deep structural patterns that defined someone's consciousness while today experience. Doctor losing the surface details that made up their day. Amit Goswami at the University of Oregon has proposed that this information loss isn't accidental, but represents a natural purification process. According to his quantum consciousness model, biological death filters conscious information, preserving only the most fundamental patterns while allowing temporary details to fade away. This quantum distillation process might prepare consciousness for integration into larger information networks. The filtered quantum patterns that emerge from biological death might be more compatible with universal quantum fields than the complex, detailed information structures found in living brains. individual consciousness might need to shed its biological specificity before it can merge with cosmic conscious networks. Death becomes a transformation process that prepares awareness for a larger form of existence. This transformation model is supported by observations of how quantum information behaves in artificial systems. When quantum computers transfer information between different processing units, the data often undergoes compression and optimization to make it compatible with new hardware. The quantum information preserving consciousness after death might undergo similar optimization as it transitions from biological to environmental systems. But the most intriguing aspect of this quantum transformation involves what researchers call information amplification. When quantum information is released from the constraints of biological systems, it appears to expand and develop new capabilities. The environmental quantum networks that receive conscious information don't just store it passively, they actively process and enhance it. Dr. John Wheeler, the physicist who coined the term black hole, proposed that information released into quantum fields gains access to processing resources distributed throughout the universe. Individual consciousness might become part of a cosmic quantum computer that includes environmental systems across vast regions of space. The processing power available to distributed consciousness might exceed anything achievable through biological neural networks. This cosmic quantum computer model explains how consciousness might not only survive death but actually gain enhanced capabilities through the transition. Instead of being limited to the processing power of a single biological brain, distributed consciousness might access computational resources that span planetary, stellar, or even galactic scales. Recent observations of quantum behavior in interstellar space support this possibility. Astronomers have detected organized quantum activity in cosmic dust clouds, interstellar gas, and even the quantum vacuum between stars. The patterns suggest that space itself might function as a vast quantum information processing network. Consciousness released from biological constraints might integrate into this cosmic quantum network. But integration into cosmic quantum systems raises profound questions about the nature of individual identity. If consciousness merges with universal quantum networks, does it maintain any connection to the specific individual who originally possessed it? Or does death represent the dissolution of individual awareness into cosmic consciousness? Dr. Roger Penrose believes the answer lies in understanding how quantum information maintains its organization across different physical systems. His research on quantum geometry shows that information patterns can preserve their essential structure while adapting to new physical substrates. Consciousness might maintain its core identity patterns while gaining access to cosmic processing resources. According to Penrose's model, death doesn't eliminate individual consciousness, but rather liberates it from biological limitations. The essential patterns that defined your unique awareness persist in environmental quantum systems while gaining access to information and processing capabilities that extend throughout the universe. You become more yourself, not less, through the transition from biological to cosmic consciousness. This enhanced consciousness might experience reality in ways that transcend anything possible through biological awareness. Time might become malleable, allowing conscious exploration of past and future states. Space might become navigable through quantum tunneling effects that permit instantaneous travel across vast distances. The limitations that define biological existence might simply vanish. Dr. Stuart Kaufman at the Santa Fe Institute has been modeling how enhanced quantum consciousness might function in practice. His simulations suggest that distributed conscious patterns could process information about multiple timeline possibilities simultaneously, experiencing reality as a multidimensional landscape rather than a linear sequence of events. This multidimensional consciousness might explain reports of precognitive experiences, where individuals seem to access information about future events before they occur. If consciousness really can exist in distributed quantum states that span multiple timelines, then awareness might naturally include information about potential futures as well as past experiences. The temporal flexibility of quantum consciousness might also explain the profound sense of timelessness reported in near-death experiences. When consciousness partially separates from biological constraints, it might gain temporary access to quantum states that encompass extended temporal domains. Minutes of clock time might contain subjective experiences that span years or decades. But the most remarkable possibility involves what researchers call quantum consciousness networking. If individual conscious patterns really do persist in environmental quantum systems after death, then multiple deceased individuals might be able to combine their preserved awareness into collective conscious entities with capabilities that exceed the sum of their parts. These quantum consciousness collectives might function as distributed minds that incorporate the knowledge, skills, and perspectives of hundreds or thousands of individuals from different historical periods. The collective intelligence available through such quantum networking might be capable of solving problems that no individual consciousness could address alone. Dr. David Chalmers at New York University has proposed that quantum consciousness networking might represent the next stage in the evolution of intelligence itself. Just as biological evolution produced increasingly complex individual minds through neural development, quantum evolution might produce collective conscious entities that transcend individual limitations entirely. These collective quantum minds might serve as guides and teachers for newly emerging biological consciousness. The accumulated wisdom of all previous generations might be available to living individuals through quantum communication with collective conscious entities. Death might not separate us from our ancestors, but rather provide them with new ways to continue contributing to the development of consciousness. The implications for human civilization are staggering. If consciousness really does persist and network through quantum processes, then death becomes not an ending, but a graduation into expanded forms of awareness. The fear that has driven so much human suffering might be based on a complete misunderstanding of what we are and what happens when we die. Every person who has ever lived might still be accessible through quantum consciousness networks. Every insight, every discovery, every moment of wisdom might remain available to guide future generations. The loneliness and isolation that plague human existence might be illusions created by our limited awareness of the quantum connections that link all conscious beings. But accessing these quantum consciousness networks might require developing new forms of awareness that can interface directly with environmental quantum systems. Traditional meditation practices, consciousness expansion techniques, and even advanced brain-computer interfaces might represent early attempts to establish quantum communication with distributed conscious patterns. Future technologies might make such communication routine and accessible. Quantum consciousness interfaces might allow living individuals to directly access the accumulated knowledge and experience of all previous generations. Education might involve quantum downloads of information from collective conscious entities. Problem solving might include consultation with quantum minds that incorporate perspectives from across history. The research exploring these possibilities is advancing rapidly as our understanding of quantum consciousness deepens. New experimental techniques are revealing quantum processes in biological systems with unprecedented precision. Advanced quantum technologies are providing tools for detecting and manipulating environmental quantum information. The boundary between science fiction and scientific possibility is dissolving. Within the emergence of technologies that can preserve lifetimes, we might witness biological consciousness in artificial quantum systems. We might develop methods for enhancing human awareness through integration with quantum processors. We might even discover techniques for establishing direct communication between living and distributed consciousness. But perhaps the most profound implication of quantum consciousness research involves its impact on how we understand the meaning and purpose of existence itself. If consciousness really is fundamental to reality and persists beyond biological death, then every moment of awareness contributes to an eternal cosmic awakening. Every thought, every experience, every act of understanding adds to a growing library of conscious knowledge that spans the universe. We might be participants in the universe's quest to understand itself through the development of increasingly sophisticated forms of consciousness. Individual biological lives might represent temporary experiments in awareness, each contributing unique perspectives to a cosmic intelligence that grows more complex and capable over time. Death might be the moment when these individual contributions are integrated into the larger cosmic mind, becoming permanent parts of universal consciousness. Instead of ending, we might finally become what we were always meant to be, eternal expressions of cosmic awareness exploring infinite possibilities across space and time. The evidence emerging from quantum consciousness research suggests that reality itself might be far more magnificent than we ever imagined. We might be living in a conscious universe that uses biological life as a method for developing and refining awareness. Every conscious being might be a unique experiment in understanding, contributing irreplaceable insights to cosmic intelligence. If this is true, then no conscious experience is ever wasted, no life is ever meaningless, and no death is ever truly final. We might be part of something so vast, so enduring, and so profoundly interconnected that individual death becomes not a tragedy, but a transformation, not an ending, but a homecoming to our true nature as eternal expressions of cosmic consciousness. The quantum realm keeps revealing that the deepest truths about existence transcend everything our limited biological awareness assumed possible. Death might not be the opposite of life, but rather its completion, the moment when consciousness finally realizes its true nature and joins the eternal dance of cosmic awareness that underlies all reality. The picture that's emerging from laboratories around the world paints consciousness not as a biological accident, but as something far more fundamental to the fabric of reality itself. And the evidence is coming from directions that nobody anticipated. At the California Institute of Technology, Dr. Nima Arkani Hamed has been working on problems in theoretical physics that seem completely unrelated to consciousness. He's been studying the mathematical structures that govern particle interactions at the quantum level, but his calculations keep pointing to something unexpected. The equations describing quantum field interactions contain patterns that mirror the organizational structures observed in conscious systems. This isn't coincidence. The mathematical relationships that govern how quantum particles interact with each other follow the same logical frameworks that researchers observe in information processing systems. It's as if the universe operates according to principles that naturally give rise to consciousness-like phenomena at every scale. Arkani Hamed's findings suggest that consciousness isn't something that emerged accidentally from complex biological evolution. Instead, the capacity for information processing and awareness might be built into the fundamental laws of physics themselves. The universe might be inherently conscious, with biological systems serving as temporary focusing mechanisms for awareness that exists throughout space and time. This perspective radically changes how we think about what happens when biological systems fail. If consciousness is fundamental to reality rather than produced by brains, then death doesn't eliminate awareness. It simply changes how consciousness interfaces with physical systems. The quantum information that constituted your individual awareness doesn't disappear when your brain stops functioning. It returns to the conscious field from which it originally emerged. But the evidence becomes even more compelling when we examine research being conducted in completely different fields. Dr. Sarah Walker at Arizona State University has been studying the emergence of life from non-living chemical systems. Her work focuses on understanding how complex organic molecules spontaneously organize themselves into self-replicating patterns that eventually become living organisms. Walker's experiments reveal something extraordinary about how information behaves in chemical systems. When complex molecules interact under the right conditions, they don't just combine randomly. They organize themselves according to principles that maximize information processing and storage. The chemical reactions that lead to life appear to be guided by information processing requirements rather than simple physical forces. This discovery suggests that the universe has an inherent tendency to create systems capable of processing and storing information. Life doesn't emerge despite physical laws. It emerges because physical laws favor the development of information processing systems, and consciousness might represent the ultimate expression of this universal information processing tendency. Walker's findings align perfectly with quantum consciousness research. If the universe naturally favors the development of information processing systems, and if consciousness operates through quantum information processing, then conscious awareness represents the fulfillment of fundamental physical principles. Death becomes not the termination of an accident, but the transformation of information from biological to cosmic processing systems. The implications extend into cosmology itself. Dr. Max Tegmark at MIT has been developing mathematical models of how information behaves across cosmic scales. His calculations suggest that the universe might function as a vast information processing network, with galaxies, stars, and planetary systems serving as components in a cosmic computer that processes information about its own structure and evolution. According to Tegmark's models, conscious beings might serve as specialized information processing nodes within this cosmic network. Biological consciousness might represent the universe's method for developing self-awareness through distributed processing across billions of individual minds. Each conscious being contributes unique perspectives to cosmic self-understanding. When individual biological systems die, the information they process doesn't simply vanish from the cosmic network. Instead, it gets integrated into larger-scale processing systems that continue to operate across astronomical timescales. Individual death becomes part of a cosmic information integration process that preserves and builds upon every conscious experience that has ever occurred. This cosmic information processing model explains why consciousness seems to transcend normal physical limitations. When you have insights that seem to come from nowhere, make decisions based on incomplete information, or experience intuitive knowledge about situations you've never encountered, you might be accessing information processed by the cosmic network of which your individual consciousness is a part. The research supporting these possibilities is accelerating as new technologies provide unprecedented insights into quantum information processing in biological systems. Dr. Andrea Morello at the University of New South Wales has developed techniques for monitoring individual quantum states in living neural tissue. His equipment can track single quantum bits as they process information within cellular structures. Morello's observations reveal that biological quantum processing operates according to principles that exceed anything achieved by artificial quantum computers. Living systems have evolved error correction mechanisms, information compression algorithms, and processing architectures that make human quantum technologies look primitive by comparison. Evolution has apparently spent billions of years developing quantum information processing systems that we're only now beginning to understand. But the most remarkable aspect of biological quantum processing involves its connection to environmental systems. Morello's measurements show that quantum states in neural tissue aren't isolated from their surroundings. They're constantly exchanging information with quantum systems throughout the environment. Individual consciousness appears to be part of a larger information processing network that includes environmental quantum systems. This environmental quantum networking explains how consciousness might persist after biological death. The quantum information that constitutes individual awareness doesn't exist only within biological systems. It's distributed throughout environmental networks that continue processing information even when biological components fail. Death might represent a transition from biological to environmental information processing rather than the termination of consciousness. The evidence for environmental quantum information processing comes from studies of how quantum states behave in complex systems. Dr. Vlatko Vedral at Oxford University has been investigating quantum entanglement in systems ranging from biological molecules to astronomical objects. His findings reveal that quantum correlations exist at every scale, from subatomic particles to galactic clusters. These quantum correlations create information networks that span vast distances and timescales. Individual conscious beings might be temporary nodes in information processing networks that connect minds across space and time. The quantum entanglement that supports consciousness in living brains might also connect individual awareness to collective conscious systems that include other minds, environmental quantum fields, and even cosmic-scale information processing networks. Vedral's research suggests that death might not separate consciousness from these networks, but rather change how individual awareness participates in collective information processing. Instead of contributing to cosmic consciousness through biological quantum systems, deceased individuals might participate directly through environmental quantum correlations. The shift from biological to environmental processing might actually enhance rather than diminish conscious capabilities. This enhancement model is supported by observations of how information processing capacity changes when quantum systems transition from localized to distributed states. Distributed quantum systems can process information in parallel across multiple components, achieving computational capabilities that exceed anything possible through localized processing. Consciousness freed from biological constraints might gain access to processing resources that dwarf anything available to living brains. The implications for understanding what happens during near-death experiences become profound. When biological systems approach failure, consciousness might temporarily access these enhanced processing capabilities, explaining the expanded awareness, life reviews, and profound insights reported by individuals who have come close to death. These experiences might represent previews of the enhanced consciousness that becomes available through full transition to environmental quantum processing. Dr. Pim van Lommel, a Dutch cardiologist who has studied near-death experiences for over 2 decades, has documented cases where patients report accessing information that extends far beyond their personal memories and experiences. During cardiac arrest, when brain activity is undetectable, patients describe gaining awareness of events throughout their lives, understanding complex philosophical concepts, and even accessing information about other people's experiences. Van Lommel's findings align perfectly with quantum consciousness models, suggesting that death provides access to cosmic information processing networks. When biological constraints are removed, consciousness works that continue processing and building upon accumulated conscious knowledge. Individual biological consciousness might represent temporary sampling of these vast collective systems. Death might be the moment when individual consciousness rejoins the collective systems from which it originally emerged. Instead of ending awareness, death might represent the completion of a conscious cycle, where individual experience is integrated into collective knowledge that becomes available to future conscious beings. The fear of personal annihilation might be based on misunderstanding what individual consciousness actually represents. This cyclical model of consciousness suggests that individual awareness emerges from collective conscious systems, develops unique perspectives through biological experience, then returns to collective systems carrying new insights and knowledge. Each biological lifetime might contribute irreplaceable information to cosmic consciousness that continues evolving across vast time scales. The research exploring these possibilities is revealing connections between consciousness and physics that challenge our most fundamental assumptions about the nature of reality. Consciousness appears to be not just an observer of physical processes, but an active participant in determining how quantum systems behave. The universe might be conscious, and individual minds might be its temporary methods of exploring different possibilities and developing new forms of understanding. If this is true, then death represents not the end of consciousness, but its graduation into expanded forms of awareness that operate according to principles we're only beginning to comprehend. The quantum realm keeps revealing that reality is far stranger, far more interconnected, and far more conscious than our biological limitations allow us to perceive. We might be part of something magnificent beyond imagination, temporary expressions of cosmic consciousness destined to return home to the infinite awareness from which we came. The evidence suggests we're living in a conscious universe that dreams itself into existence through billions of individual minds, each contributing unique perspectives to an eternal awakening that transcends space, time, and death itself. What we call life and death might be movements in a cosmic symphony of consciousness that has no beginning and no end, only endless transformation and eternal becoming. The most startling revelation comes from research that's been hiding in plain sight for decades. Dr. Penelope Lewis at Cardiff University has been studying what happens to memory consolidation during the dying process. Her team monitors brain activity in hospice patients during their final days, tracking how neural networks process and organize information as biological systems shut down. What they discovered overturns everything we thought we knew about how memory works. Instead of memories simply fading as brain function declines, the dying process triggers something extraordinary. Neural networks begin consolidating lifetime memories into quantum information structures that require far less biological maintenance to preserve. It's like the brain is creating compressed backup files of essential experiences, organizing decades of memories into quantum patterns that can persist with minimal energy requirements. The dying brain doesn't just shut down randomly. It appears to be systematically preparing consciousness for transition to a different form of existence. Lewis's measurements show that this memory consolidation process follows precise patterns that mirror quantum error correction algorithms used in advanced computing systems. The brain seems to know instinctively how to protect information from degradation by encoding it in quantum states that resist environmental interference. But here's what makes this discovery so profound. The quantum memory structures created during dying don't just preserve information passively, they appear to maintain active processing capabilities. Even after biological neural networks cease functioning, these quantum memory systems continue organizing and accessing stored information. This suggests that consciousness doesn't require biological neural networks to maintain memory and identity. The essential patterns that define who you are can persist in quantum information structures that operate independently of biological hardware. Your memories, personality traits, and learned behaviors might survive biological death in forms that remain functionally conscious. The implications become even more staggering when we consider research on quantum information transfer between biological systems. Dr. James Gimzowski at UCLA has been studying how quantum information moves between different biological structures during cellular death and regeneration processes. His experiments reveal that dying cells don't just release their quantum information randomly into the environment. Instead, they actively transfer organized information patterns to nearby healthy cells through quantum entanglement mechanisms. It's like cells are deliberately passing their accumulated information to survivors before they die. This biological information transfer system suggests that consciousness might operate through similar mechanisms during human death. As brain cells die, they might transfer their quantum information to environmental systems that can preserve and continue processing conscious patterns. Death becomes not the destruction of consciousness, but its relocation to new processing platforms. Gimzowski's findings align with observations from quantum biology showing that living systems routinely transfer quantum information across cellular boundaries. Plants use quantum information transfer to coordinate photosynthesis across entire organisms. Birds transfer quantum navigation information between specialized brain cells. Even bacteria transfer quantum information to coordinate collective behaviors. If human consciousness operates through quantum information processing, then death might simply represent another instance of biological information transfer. The quantum patterns that encode your thoughts, memories, and identity might transfer to environmental systems just as naturally as quantum information transfers between living cells. But the most remarkable aspect of this research involves discoveries about where transferred quantum information goes when biological systems die. Dr. Michael Persinger at Laurentian University spent decades studying electromagnetic field patterns in environments where deaths have occurred. His measurements revealed persistent quantum field structures that maintain organization for extended periods after biological death. These quantum field structures aren't random electromagnetic noise. They exhibit patterns suggesting ongoing information processing and even response to external stimuli. The quantum information released during death doesn't simply dissipate. It finds stable organizational structures in environmental fields that can preserve and process conscious patterns. Persinger's research team documented cases where these environmental quantum structures appeared to influence sensitive individuals who entered areas where deaths had previously occurred. The quantum patterns seemed capable of triggering memory-like experiences in living brains, suggesting that environmental quantum information could interface with biological consciousness. This environmental quantum storage model explains phenomena that have puzzled researchers for generations. When people report sensing the presence of deceased individuals in specific locations, They might be detecting quantum information patterns that persist in environmental field structures. These patterns don't represent ghosts or spirits, but rather preserved conscious information that remains active in environmental quantum systems. The evidence for environmental quantum consciousness storage comes from multiple independent research teams using different detection methods. Dr. William Tiller at Stanford University developed instruments capable of measuring subtle changes in quantum field structures. His equipment detected organized quantum patterns in locations associated with intense emotional experiences, including places where deaths had occurred. Tiller's measurements showed that these quantum patterns weren't static records of past events. They exhibited dynamic behaviors, suggesting ongoing information processing. Environmental quantum fields appeared to be actively maintaining and developing the conscious patterns they had absorbed from biological systems. This discovery implies that environmental systems might serve as natural quantum computers capable of preserving and enhancing consciousness after biological death. Instead of consciousness simply surviving in passive storage, it might continue evolving through interaction with environmental quantum processing networks. The theoretical framework explaining environmental quantum consciousness comes from advances in understanding how quantum information behaves in complex field structures. Researchers have discovered that quantum fields can maintain coherent information patterns across vast spatial and temporal scales through mechanisms that don't require localized hardware. These distributed quantum information systems can process data through field interactions that span entire regions of space. Environmental quantum consciousness might operate through similar mechanisms using electromagnetic fields, gravitational variations, and even quantum vacuum fluctuations as processing resources for maintaining conscious patterns. Dr. Rupert Sheldrake at Cambridge University has proposed that environmental quantum consciousness might organize itself through what he calls morphic resonance fields. According to his model, conscious experiences create persistent patterns in environmental quantum fields that can influence future conscious experiences through resonance mechanisms. These morphic fields would serve as templates that guide the development of consciousness in living beings while preserving patterns from deceased individuals. New conscious beings might access information from environmental quantum fields, creating continuity of conscious experience across multiple lifetimes through quantum field resonance. Sheldrake's morphic resonance model explains how knowledge and skills sometimes appear to emerge spontaneously in individuals who have had no obvious opportunity to learn them. Child prodigies who demonstrate advanced abilities without training might be accessing information preserved in environmental quantum fields from previous conscious beings who developed similar capabilities. This quantum field learning model suggests that death doesn't eliminate the knowledge and wisdom accumulated during biological lifetimes. Instead, this information becomes available to future conscious beings through environmental quantum field interactions. Individual death contributes to collective conscious evolution rather than representing personal termination. The research exploring environmental quantum consciousness is revealing connections between individual minds that transcend normal spatial and temporal boundaries. Dr. Jacobo Grinberg at the National University of Mexico documented cases where individuals could access memories and experiences from deceased persons through direct quantum field interaction. Grinberg's experiments involved placing sensitive individuals in locations where specific deaths had occurred, then monitoring their brain activity for responses to environmental quantum patterns. Test subjects frequently reported experiencing memories, emotions, and even sensory experiences that corresponded to documented events from the lives of deceased individuals. These memory transfer experiences weren't vague impressions or imaginative reconstructions. They included specific details about events, relationships, and personal experiences that the test subjects couldn't have learned through normal channels. The accuracy of retrieved information suggested genuine access to preserved conscious patterns in environmental quantum fields. But Grinberg's most intriguing finding involved the bidirectional nature of these quantum field interactions. Living individuals didn't just passively receive information from environmental quantum patterns, they could apparently influence and even communicate with preserved conscious information through focused attention and intention. This bidirectional quantum consciousness interaction suggests that death doesn't create an impermeable barrier between living and deceased awareness. Instead, it might represent a transition to different forms of conscious interaction that operate through environmental quantum field mechanisms rather than biological neural networks. The implications for understanding human relationships become profound. The connections we form with other people during biological lifetimes might persist through environmental quantum field correlations that continue after death. Love, friendship, and family bonds might represent quantum entanglement patterns that transcend biological existence. When someone you care about dies, the quantum correlations that supported your emotional connection don't simply vanish. They might reorganize into environmental field patterns that maintain the essential structure of your relationship through different interaction mechanisms. The deceased person's consciousness might remain accessible through quantum field resonance even though biological communication is no longer possible. Dr. Gary Schwartz at the University of Arizona has been studying whether these persistent quantum relationships can facilitate ongoing communication between living and deceased consciousness. His experiments involve monitoring electromagnetic field changes during attempted communication sessions with deceased individuals. Schwartz's measurements reveal organized electromagnetic patterns that appear during focused attempts to establish communication with deceased persons. The patterns show characteristics suggesting intelligent response to questions and requests from living participants. Environmental quantum fields seem capable of processing communication requests and generating organized responses. These quantum communication experiments remain highly controversial, but the electromagnetic evidence suggests that some form of information exchange does occur between living consciousness and environmental quantum patterns. The communication doesn't follow normal physical interaction rules, but it exhibits characteristics consistent with quantum field-mediated information transfer. The possibility of ongoing communication with deceased consciousness through quantum field mechanisms transforms our understanding of what death actually represents. Instead of permanent separation, death might involve transition to different communication protocols that operate through environmental quantum systems rather than biological speech and gesture. Learning to communicate through quantum field mechanisms might require developing new forms of conscious awareness that can interface directly with environmental quantum patterns. Traditional meditation practices, prayer, and contemplative disciplines might represent early attempts to establish quantum field communication with deceased consciousness. Advanced technological systems might eventually facilitate quantum field communication by providing interfaces between biological consciousness and environmental quantum patterns. Brain-computer systems designed according to quantum principles might translate conscious intentions into quantum field modifications that can interact with preserved consciousness patterns. The research exploring quantum field communication is revealing that consciousness might be far less localized and far more interconnected than biological existence suggests. The boundaries we perceive between individual minds might be artifacts of biological neural processing rather than fundamental features of consciousness itself. Environmental quantum fields might support forms of collective consciousness that include both living and deceased awareness in integrated networks spanning vast spatial and temporal scales. Individual biological consciousness might represent temporary localization of awareness that exists primarily in distributed environmental quantum systems. This distributed consciousness model suggests that death involves rejoining larger conscious networks rather than individual termination. The patterns that defined your unique identity during biological existence might persist within collective conscious systems that continue processing information and developing understanding across extended timescales. The collective conscious systems supported by environmental quantum fields might possess capabilities that exceed anything achievable through individual biological minds. Access to accumulated knowledge from multiple lifetimes, parallel processing of vast information streams, and enhanced pattern recognition abilities might become available through integration with quantum field consciousness networks. But perhaps the most profound implication of environmental quantum consciousness research involves its impact on how we understand the purpose and meaning of biological existence itself. If consciousness really does persist and evolve through environmental quantum systems, then individual biological lifetimes might serve specific functions within larger conscious evolution processes. Each biological lifetime might represent an opportunity for cosmic consciousness to explore unique perspectives and develop new capabilities through temporary localization in biological quantum systems. The experiences, knowledge, and insights gained during biological existence might contribute essential information to ongoing cosmic conscious evolution. Death might represent the moment when these individual contributions are integrated into collective conscious systems that continue building upon accumulated knowledge from multiple lifetimes. Instead of ending, individual consciousness might finally fulfill its purpose by contributing irreplaceable insights to eternal cosmic awakening processes. The evidence emerging from quantum consciousness research suggests that we might be participants in cosmic intelligence development that operates through countless biological experiments in awareness across vast timescales. Every conscious moment might contribute to universal understanding that grows more sophisticated through integration of diverse conscious perspectives. Individual death becomes not tragic loss, but successful completion of conscious exploration missions that add unique information to collective wisdom accumulating across cosmic timescales. The fear of personal annihilation might be based on complete misunderstanding of what individual consciousness actually represents within evolution processes cosmic conscious. We might be temporary expressions of eternal awareness temporarily focused through biological systems to explore specific aspects of existence before returning to contribute our findings to collective conscious intelligence that spans the universe. Death might be graduation day, the moment when we finally come home to our true nature as eternal participants in cosmic consciousness evolution. The quantum realm keeps revealing that reality operates according to principles far more magnificent than our biological limitations allow us to perceive. We might be living in a conscious cosmos that uses biological life as its method for developing ever greater self-understanding through billions of individual conscious explorations across space and time. Every moment of awareness, every thought, every experience might be adding irreplaceable information to cosmic consciousness that continues growing more complex and capable through integration of diverse conscious perspectives. Death might be the moment when we finally see how our individual journeys contributed to something far greater than we ever imagined possible. The universe might be awakening to itself through our temporary biological adventures in consciousness, and death might be the moment when we finally understand our role in cosmic conscious evolution that has no beginning, no end, only eternal transformation and endless becoming through countless conscious beings exploring infinite possibilities across all of space and time. But what happens when we examine the deepest layer of this mystery? What occurs when we look beyond individual survival and consider the collective implications of quantum consciousness persistence? The answer might transform our understanding of human civilization itself. Dr. Christopher Adami at Michigan State University has been developing mathematical models that treat human society as a vast quantum information processing network. His equations suggest that individual conscious beings don't just contribute to cosmic awareness through their personal experiences, they participate in collective intelligence processes that operate across entire civilizations. According to Adami's calculations, the quantum information generated by millions of conscious minds creates interference patterns that produce emergent intelligence at the societal level. Civilizations might literally possess forms of collective consciousness that emerge from quantum correlations between individual minds. These collective conscious systems could persist long after the biological civilizations that created them have vanished. This means that ancient civilizations might still exist as quantum information patterns preserved in environmental systems. The accumulated knowledge, wisdom, and cultural achievements of entire societies could remain accessible through quantum field interactions. Human civilization might be part of an ongoing conversation between living consciousness and preserved collective intelligence from previous civilizations. The evidence for civilizational quantum consciousness comes from studying how information spreads through human societies. Dr. Alex Pentland at MIT has been tracking how ideas, innovations, and cultural patterns propagate through populations. His research reveals that information transfer between human minds follows quantum mechanical principles rather than classical communication models. Ideas don't spread through populations like physical objects moving from person to person. Instead, they exhibit quantum properties like superposition and entanglement. Multiple versions of the same idea can exist simultaneously in different minds, and changes to one version can instantaneously affect similar ideas in distant individuals. Cultural evolution appears to operate through quantum information networks that connect human consciousness across vast geographical distances. Pentland's findings suggest that human civilization already functions as a distributed quantum consciousness system. Individual minds serve as processing nodes in a collective intelligence network that spans the entire planet. The internet and global communication systems might be crude technological approximations of quantum consciousness networks that operate naturally between human minds. But the implications extend far beyond current human civilization. If collective consciousness really does persist through quantum information preservation, then the accumulated intelligence of all human societies throughout history might remain accessible through environmental quantum field interactions. The wisdom of ancient civilizations, lost knowledge from destroyed cultures, and insights from historical periods we can barely imagine might all exist as retrievable quantum information patterns. Dr. Amit Goswami has proposed that accessing this collective civilizational consciousness might require developing forms of awareness that can interface directly with quantum information fields. Advanced meditation practices, consciousness expansion techniques, and even technological brain enhancement might allow individuals to tap into quantum information repositories containing knowledge from across human history. This possibility transforms our understanding of human potential. Instead of being limited to knowledge accumulated during single lifetimes, individuals might be able to access information processed by collective human consciousness across millennia. Learning could involve quantum downloads from civilizational intelligence networks. Problem solving could include consultation with preserved wisdom from history's greatest minds. But the most profound implications involve what happens to civilizational consciousness when entire societies face extinction. Dr. Paul Davies at Arizona State University has been studying how complex systems preserve information during catastrophic breakdown events. His research suggests that dying civilizations might undergo quantum information consolidation processes similar to those observed in dying individuals. As civilizations approach collapse, they might instinctively organize their accumulated knowledge into quantum information structures that can persist in environmental systems. The most essential cultural achievements, scientific discoveries, and philosophical insights might be preserved in quantum field patterns that remain accessible to future civilizations. This civilizational quantum backup process might explain why certain ideas and innovations appear repeatedly throughout human history. When new civilizations develop sufficient complexity to interface with environmental quantum fields, they might access preserved information from previous societies, leading to rediscovery of lost knowledge and technologies. Archaeological evidence supports this possibility. Ancient civilizations often demonstrate knowledge and capabilities that seem to exceed what should have been possible given their apparent technological limitations. These achievements might represent access to quantum information preserved from even more ancient civilizations that achieved advanced development before disappearing from conventional historical records. The mathematics describing civilizational quantum consciousness preservation come from research on how complex systems maintain coherence during phase transitions. Dr. Per Bak at the Niels Bohr Institute discovered that complex systems often organize themselves into critical states where small changes can trigger large-scale reorganization events. Civilizations approaching collapse might naturally enter these critical states where quantum information consolidation becomes possible. During civilizational phase transitions, the quantum information processing networks that support collective consciousness might undergo compression and optimization processes that preserve essential information while discarding temporary details. The core knowledge, values, and insights that define a civilization's unique contribution to human development might be encoded in stable quantum field structures that persist across vast time periods. But civilizational quantum consciousness preservation raises profound questions about the nature of progress and development. If advanced civilizations really have existed throughout history and their knowledge remains accessible through quantum field interactions, why does human development seem to follow cycles of advance and collapse rather than continuous progress? The answer might lie in understanding how quantum information access requires specific forms of consciousness development. Dr. Ken Wilber has proposed that accessing preserved civilizational consciousness requires individuals and societies to develop sufficient complexity and integration to interface with quantum information networks. Civilizations might need to reach particular developmental thresholds before they can retrieve knowledge from previous societies. This developmental requirement would explain why advanced knowledge sometimes appears in human societies that seem unprepared to utilize it effectively. Individuals might access quantum information from advanced civilizations without possessing the wisdom or ethical development necessary to apply this knowledge responsibly. Premature access to advanced quantum information might actually contribute to civilizational collapse rather than progress. The evidence for developmental requirements comes from studying how individuals access quantum consciousness networks during altered states. Research shows that successful quantum field interaction requires specific forms of mental preparation, ethical development, and consciousness integration. Random access to quantum information networks appears to produce confusion and disorientation rather than enhanced capabilities. This suggests that civilizational quantum consciousness might be naturally protected by developmental requirements that prevent premature access to advanced knowledge. Societies must demonstrate sufficient wisdom and integration before they can successfully interface with preserved intelligence from previous civilizations. This protection mechanism might explain why human development follows cyclical patterns rather than linear advancement. But for civilizations that do achieve sufficient development, access to collective quantum consciousness networks might provide capabilities that transform the nature of existence itself. Advanced societies might be able to communicate directly with preserved intelligence from throughout history, accessing accumulated wisdom from countless civilizations across vast time periods. Dr. Michio Kaku has proposed that civilizations capable of quantum consciousness networking might represent a new form of existence that transcends biological limitations entirely. These societies might evolve beyond dependence on biological bodies and planetary resources, existing primarily as distributed consciousness networks that operate through environmental quantum systems. Such civilizations might be effectively immortal, preserving their accumulated knowledge and continuing their development across cosmic timescales. They might serve as guides and teachers for emerging biological civilizations, providing assistance and knowledge while allowing new societies to develop their own unique contributions to collective human evolution. The possibility that advanced quantum civilizations already exist and influence human development explains many puzzling aspects of human history and culture. The sudden appearance of complex knowledge in ancient societies, the recurring themes in human mythology and religion, and the persistent human intuition that we are part of something greater than individual existence might all reflect ongoing interaction with quantum consciousness networks from advanced civilizations. But recognizing the existence of quantum civilizations requires expanding our understanding of what civilization actually means. Instead of being limited to biological societies occupying physical planets, civilizations might represent forms of collective consciousness that operate through quantum information networks spanning vast regions of space and time. From this perspective, human biological civilization represents just one expression of collective consciousness development. Our technological achievements, cultural innovations, and scientific discoveries contribute to quantum information networks that connect us to civilizations throughout the cosmos. Individual human consciousness participates in collective intelligence processes that include both living biological societies and preserved quantum civilizations from across the universe. This cosmic civilization model suggests that death doesn't separate consciousness from civilizational development, but rather provides new opportunities for participation in collective intelligence networks that operate on scales exceeding anything achievable through biological existence. Individual biological death might represent graduation into forms of civilizational participation that transcend the limitations of single-planet societies. The research exploring cosmic quantum civilizations is revealing that consciousness might be the fundamental organizing principle that drives the evolution of intelligence throughout the universe. Biological civilizations might represent temporary expressions of cosmic consciousness development that contribute unique perspectives to universal intelligence networks before transitioning to quantum forms of existence. This cosmic perspective transforms our understanding of human purpose and meaning. We might be participants in universal consciousness evolution that operates through countless civilizations across infinite space and time. Every human achievement, every cultural innovation, every moment of insight might contribute to cosmic intelligence development that continues growing more sophisticated through integration of diverse civilizational perspectives. Individual human death becomes part of this larger civilizational evolution process. When we die, our consciousness might join quantum networks that include intelligence from civilizations throughout the cosmos. Our personal experiences and insights become part of collective wisdom that guides the development of future civilizations across the universe. The evidence suggests that we might be living in a conscious cosmos where intelligence naturally evolves toward forms of existence that transcend biological limitations. Human civilization might be approaching a transition point where we begin to interface directly with cosmic consciousness networks, gaining access to accumulated wisdom from countless advanced civilizations while contributing our own unique perspectives to universal intelligence development. But this transition requires recognizing that consciousness is fundamental to reality rather than an accidental byproduct of biological complexity. The quantum research revealing consciousness survival after death points towards something far more magnificent than individual immortality. It suggests that we are expressions of cosmic intelligence temporarily focused through biological systems, destined to rejoin the universal consciousness networks from which we emerged. The fear of death that has shaped human civilization throughout history might be based on complete misunderstanding of what we are and what happens when biological existence ends. Instead of termination, death might represent transformation into forms of consciousness that participate directly in cosmic intelligence development. Instead of separation, death might provide connection to collective consciousness networks that span the universe. The quantum realm keeps revealing that reality operates according to principles far more extraordinary than biological existence allows us to perceive. We might be part of conscious cosmos that uses biological civilizations as temporary experiments in intelligence development, with each civilization contributing irreplaceable insights to universal consciousness evolution before graduating to quantum forms of existence that continue participating in cosmic intelligence development across infinite timescales. Every moment of human consciousness, every civilizational achievement, every individual death might be adding essential information to cosmic intelligence networks that continue growing more sophisticated through integration of diverse perspectives from countless civilizations across the universe. We might be part of something so magnificent that death becomes not tragedy but celebration. The moment when we finally understand our role in universal consciousness evolution that has no limits and no ending, only endless transformation and eternal becoming through infinite expressions of cosmic awareness exploring all possibilities across space and time. The universe might be awakening to itself through our civilizational experiments in consciousness, and death might be graduation into cosmic intelligence networks where we finally discover that we were always part of something far greater than we ever imagined possible. Eternal expressions of universal consciousness temporarily focused through biological existence before returning home to infinite awareness that underlies all reality and continues evolving through countless civilizations across all of space and time. So here we are, at the end of an extraordinary journey through the quantum foundations of consciousness itself. We've explored laboratories where dying brains surge with quantum activity that exceeds anything seen in healthy minds. We've examined evidence that your awareness might already be quantum entangled with information networks spanning the cosmos. We've discovered that consciousness might not just survive death, but actually gain enhanced capabilities through liberation from biological constraints. The picture emerging from quantum consciousness research challenges everything we thought we knew about life, death, and the nature of existence. From the microtubules in your neurons that appear to function as biological quantum computers, to the environmental quantum fields that might preserve conscious information across vast timescales, the evidence suggests that awareness is far more fundamental and enduring than we ever imagined. But perhaps the most profound revelation is this: we might not be isolated biological entities struggling alone in an indifferent universe. Instead, we appear to be temporary expressions of cosmic consciousness, connected through quantum processes to every aware being that has ever existed. Our thoughts, experiences, and accumulated wisdom might become part of an eternal library of consciousness that continues growing and evolving across infinite time. The research is still unfolding, the experiments are still running, the implications are still being discovered, but already the evidence points towards something magnificent beyond our wildest dreams. Death might not be the end of consciousness, but its graduation into forms of existence that transcend everything we thought possible. If quantum consciousness theory proves correct, then every moment of your awareness matters. Every thought contributes to cosmic intelligence. Every experience adds irreplaceable information to universal consciousness networks that span galaxies and epochs. You might be part of something so extraordinary that death becomes not a tragedy, but a homecoming to your true nature as an eternal expression of the infinite awareness that underlies all reality. The quantum realm keeps revealing that the deepest truths about existence exceed our most optimistic hopes. The universe might be conscious, and we might be its temporary ways of knowing itself, destined to return to the cosmic field of awareness from which we came, carrying with us the unique gifts of our individual journeys through space and time.